So here we go. We want to use synthetic or long division to find the missing or remaining factor. So on one side of this equation, we have a quartic polynomial with 5 terms. Now, if it's 4th degree, what's the most number of x-intercepts this can have? 4. And so there should be 4 roots, right? Potentially. And so each one of those roots you could put into a factor, like this one, this one, this one, and 1 is missing, right? So let me ask you a different question, and I'm going to write it up here. If I had 100 equals 2 times 2 times 5 times x, couldn't we solve this algebra problem by first dividing by 2 and then dividing by 2 again and then dividing by 5 and finally getting the answer? Yep. Well, guess what we're going to do with this problem? We are going to take this quartic and divide by this first linear binomial. And we'll end up with a cubic. And then we're going to divide that by the next term, which will give us a quadratic. And then we'll divide by the next term, and we'll end up with a linear binomial. That's the plan. It is so much fun. Here we go. So I propose synthetic division because it's fastest. So let's start by writing this quartic polynomial with 5 terms with coefficients only. 1, 3, negative 24, negative 28, and 48. Now, we're going to divide by this first linear binomial. And if this is positive 6, what do we divide by? Negative 6. Now, before we do any division, I want to ask you a question. If we were going to graph this, if we had this linear binomial that was positive 6, what would the x-intercept be? Negative 6. So essentially, what are we dividing by? The actual root is what we're dividing by. Okay? Let's do the process. Take the 1, drop it. Negative 6 times 1, negative 6. 3 minus 6, negative 3. Negative 6 times negative 3, positive 18. Now we combine these using the signs in front. Negative 24 plus 18 is negative 6. Negative 6 times negative 6 is positive 36. Negative 28 plus 36, positive 8. Negative 6 times 8 is negative 48. 48 minus 48 is remainder 0. Now, recall that this 1, 3, 24, 28, 48 was x to the 4th, x to the 3rd, x squared, and x. And we divided by this x linear binomial, so what does this 1 represent? X cubed minus 3x squared minus 6x plus 8. Okay. So now we have a cubic polynomial with 4 terms, and we are going to divide that by our next linear binomial. And so if this is x plus 2, what are we going to divide by? Negative 2. And by the way, if our term is x plus 2, where is the x-intercept? Negative 2. So we're dividing by the actual root. Let's do this. Drop the first term. Negative 2 times 1 is negative 2. Negative 3 minus 2, negative 5. Negative 2 times negative 5 is positive 10. Negative 6 plus 10 is positive 4. Negative 2 times 4 is negative 8. Remainder 0. So what we did here is we had a cubic, we divided by a linear, and now x cubed is x squared minus 5x plus 4. And so now we're going to divide by this next linear binomial, x minus 1. What are we going to divide by? Positive 1. And where is the root? 1. Yeah. Okay. So, lead coefficient, drop it down, there's the 1. 1 times 1 is positive 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 4 minus 4 is 0. We did an x squared divided by x, so we are left with 1x minus 4. There it is. What's the last? X minus 4. Oh, here, I've been graphing these and you can't see them. I'm sorry. So if this is x minus 4, where does it cross the x-axis? Positive 4, right like that. And we know the lead coefficient is positive, so the right side is up. The degree is even, so the left side is the same. Cross is at positive 48. All the multiplicities are 1. So there it is. Here's number 3. Oh. Silly Dave. 5 times 25 is plus 125, not 100. Okay, so minus 104 would be 21. And then that would be minus 105, and that's remainder 0. So x first, x third, there's 3. So 1, 3, 6, 18, negative 7, negative 12, remainder 0. All right, let's go back to number 2. This problem says use synthetic or long division to find the factors of the given polynomial if you know one of the roots is x equals 8. All right, so if you'll notice, we have a cubic polynomial with 4 terms. If we have a cubic, what's the most number of x-intercepts we could have? 3. Okay. Now it says we know one of the roots is x equals 8. Right? So we know one of them, which means there's going to be 2 more. Right? Okay, I'm going to draw a little picture here. If we know one of the roots is at x equals 8, 1, 2, 3, 4, 5, 6, 7, 8, how would we represent this root of 8 in a linear binomial? X minus 8. And so at this point, the only thing we can do is divide the cubic by the linear, and what should we get inside this parentheses? A quadratic. And then we'll have to look at it and see if we can solve it. Okay? So let's set up this cubic for synthetic division with the coefficients 1, minus 9, minus 4, and 96. Now, here's where many students get confused. The root is 8. The linear binomial is negative 8. What do we divide by? Positive 8. We divide by the root. Excellent. Okay, let's do it. Drop the 1. 1 times 8 is 8. Negative 9 plus 8 is negative 1. 8 times negative 1 is negative 8. Negative 4 minus 8 is negative 12. And 8 times negative 12 is negative 96. And that gives remainder 0. So we started out with x cubed. What are we going to end up with? X squared minus 1, x minus 12. So this is x squared minus x minus 12. Okay. So now if this is a quadratic, what's the most number of x-intercepts this could have? 2. Now, there's 2 ways that we could find them. We could check number 1, can we factor? And if we can, then we're all set. And what do we do if we can't factor? Quadratic formula. Okay, so I'm just going to write down here, we have x minus 8. Are there 2 numbers that multiply to negative 12 and add to negative 1? Yeah, right on, I heard it. X minus 4 and x plus 3. Can we graph that equation now? Yes, we already have that one. That's going to be 1, 2, 3, 4. That's going to be minus 3. 96. Right side is up. It's odd. Left side is down. All the multiplicities are 1. It's going to look something like that. If you can do that on your own, flip the page over and look at number 4. Give that a whirl. I'll do it while you're doing it. Let's see, if we have a root at negative 4, that means we're going to have x plus 4. So we're going to go 1, 4, 1. Hey class, I'm going to interrupt you and give you a warning right here. Quadratic term, cubic term, no, I said that wrong. Quartic term, cubic, quadratic, linear. What term is missing? constant. So what do we need to put for our division? Yeah, a 0. Okay, so 1, negative 4, 0, 0, negative 1, 4. Okay, so that was x to the 4th. This is going to be x to the 3, x squared, x. So this looks like x cubed minus x. Get this far and then we'll work together some more. So I'm looking at this x cubed minus x. Is there anything common that we can factor out of both of these terms? An x. When we do that, we get x squared minus 1. So there's the quadratic, there's the constant. The linear term is missing. So just for fun, I'm going to write in plus 0x. Can x squared plus 0x minus 1 be factored? In other words, are there two numbers that multiply to negative 1 and add to 0? One and negative 1? Like that. Yeah. Guess what? We just factored this. Where are all the roots, or the x-intercepts? We got one at negative 4. This one would be 0. This one would be negative 1. And this one would be positive 1. All the multiplicities are 1, so that's going to go straight through. Let's go back up to this original equation. What's the y-intercept? 0. The lead coefficient is positive, so right side is up. We're even, so the left side is the same. This should look like something like that.